Yes, sure. Thanks for having me. So Avalanche is different from other blockchain architectures because it's a multi-chain system. So it's not a single chain similar to ecosystems like Ethereum. It's a network of interoperable blockchains, right? And this has many effects on how the network functions, and it's very, very different. So if you interact with Avalanche, you may not always interact with the same blockchain, but with specialized blockchains that are developed for special use cases. And by enabling this network of multiple blockchains, we can cater much better to unique requirements of enterprises or certain communities, because they don't have to come all to consensus on how they want to structure their blockchain, but they can make individual decisions that cater much better to their unique requirements. So next to our multi-chain architecture that I just mentioned, we also have a very short time to finality, right? So finality in the Avalanche network takes around 800 milliseconds, so just under a second. And that enables a lot of use cases that are not possible on chains that have, like finality that goes far beyond that, maybe takes minutes. Especially if you look into financial applications, right? Most financial applications won't function if it just takes so long. And I think that's why we see a lot of adoption in the institutional finance space, but also in the gaming space, because both of these industries really rely on very fast finality and a Web 2 user experience. This is due to Avalanche consensus, right? So Avalanche consensus is very different from many other consensus mechanisms out there. It's based on subsampling, right? So instead of holding a centralized election or anything, this is like a lengthy and very inefficient process. What we are doing is subsampling. You can maybe compare it with what we do after elections in our country, right? So instead of like counting all the votes, what we're doing is we're taking subsamples. So we're asking people exiting the polls and ask them for their opinion. And then based on that, we can use some statistic tricks, and then we can have a pretty good understanding of where the overall network is leaning towards. And since we're doing a binary choice and consensus, we can, with very, very high probability, already know the outcome of our election between two different options, way, way faster than other consensus mechanisms can. So Avalanche subnets are independent blockchains in the Avalanche ecosystem, right? So now if we have, let's say, an enterprise that wants to bring some of their business on chain, they can do that on a public permissionless blockchain, but this may, have many risks for them, right? Compliance risk. They don't want to involved in any, money laundering or any of this kind. So they really want to reduce their exposure to public permissionless blockchains. So what they can opt for is they can either alone or with a set of trusted partners interact on the chain, so have all these security features, all the accountability, the traceability, the record, all these benefits of blockchains without exposing yourself to all these risks. So what we see a lot is financial institutions tokenizing assets on subnets. And this has many benefits, as I said, but also not only when it comes to compliance, but also when it comes to gas, right? Like, so especially when we look at the fees that users have to pay on public permissionless blockchains, this can be done differently on blockchains in the Avalanche network. So every Avalanche blockchain has completely independent fees, right? Especially with fee spikes on public permissionless blockchains due to NFT drops or all kinds of other network activity or just price changes of the fee asset. This can be a huge risk for business operations if, suddenly on one day, the operation that just costed $1 yesterday now costs $300. This is enabled by the subnet architecture. The interoperability is the key feature of Avalanche, right? Like anyone could just, launch a blockchain with Avalanche consensus, just fork the code base. But what makes the difference is being part of the Avalanche network, meaning you have native interoperability with all the other networks in the Avalanche ecosystem. And if you go through our primary network, also with many other popular blockchains like Ethereum or any other popular networks. So this interoperability, like when it comes to interoperability is easy. But it gets hard when you want to reduce a trust assumption on third parties, right? Like I can very easily create interoperability between any two blockchains if I have a set of trusted third parties. With Avalanche, we found a way to not introduce an additional party, but just reuse the Avalanche network, which is very powerful, has more than 1,800 validators. So it's very decentralized, very secure, and just leverage the network as itself for this interoperability. And this creates an environment where businesses can use all these blockchain features, but also in a compliant and a secure way, while maintaining interoperability with a larger blockchain space. And this is really the main feature of the Avalanche network.